Hello everyone, my name is Ingrid Yuritsa Paez PH. I am a PhD student and, and I am working in the design and 3D printing, manufacturing and implementation of the formal actuators. In this day, and I am talking about design and 3D printing of an actuator from elastomer using as functional matter. Okay, to begin with, we are going to talk about what is the motivation of the word. Everything was word from the fact that in 2020, the Science Report magazine published an article about what are the 10 challenges of robotics. And one of the 10 challenges of robotics is appeared on design of bio-inspiring robots from materials than unmoldable and deformable materials. This is where the concept of soft robotics was born. Okay, well, the material selected for the design and manufacturing of the deformable actuator in this case is a Coflex 0030, and the second material is Dragon Skin 0010. And this is the commercial presentation, and select the material is depends what is your main characteristics or what is your principal objective. In my case, is super important and elasticity and what is the percent and flexibility, and that we look for in our materials. To carry out our project, we generate designs step by step for the design, manufacturing and construction of the deformable actuator. In the first part, you can see and they select the material. We make a design in 3D of the shape of the mold. After that, what we do is that they mix the material into the mold, and we will begin in the second part, and that is the aligned. In this case, and we are doing the manufacturing part, the design and 3D printing for a mold, and because don't have a machine that allow me to pour the material and press it automatically. Therefore, the process takes a little longer, and the manufacturing of the actuator is a bit handmade. It's very important to follow each of all the step by step described in this diagram, and we need skipping any of the steps, as it will help us to obtain an actuator made from an elastomeric material. We need this diagram is also describe how to start the characterization of the material for the study of the kinematics of the actuator, because it's very important to know all the characteristics of our new piece. And as this will also help us to know what is can serve us and when we want to implement in and rolling sets as possible. Okay, in the following image, we already see how we meet the materials in the first part, and then we deposited the material in the mold previously elaborated piece, and then you need reset the piece for 60 hours approximately. It depends the size the piece, and it depends the material. In this case, when when you use EcoFlex, you need a long time to reconcile the materials. Okay, in this image you can see the finally and manufacturing and construction the actuator, and it is important that mentioned and the manufactured have two parts. The first part is a flexible part. This part is elaborated about the EcoFlex, and the second part that it is a rigid part is designed with dragon skin. The rigid part will help us to give the duration of the flexion and extension of the actuator. Okay, and then once we have to complete part of the actuator, we perform the functional tests, and after this we proceed to the kinematic characterization to find out all the characterization of our actuator. Okay, in this image, see how too many are the degree of inflation. It's important to know what is the mass inflation achieving with what, how the weight varies and a function of the air that is injected into it, and we make a characterization where we obtain the angle of the position, any positions, which is the position exactly in X and Y, and what is the angle and the displacement in each position and second of time. Okay, it is important to mention that activation of this actuator is quickfied. It is done by air, and therefore it is your behavior is the similar on and off. That's all. Is very important to know angle, because from there it can be used to do a test control in a more robot system that is being implemented in one robotic system. Okay, finally we worked with a deformable material. We have a not linear system. It is different from conventional actuator, and what we are proposing in the design and this actuator from different deformable materials and deformable materials or soft material, and implement them in a rehabilitation system or service robots, because it is the type mechanism where people have to move with the device and not exposed to injury. And this type of materials that are not risky and are not directly connected to the electric current, that are totally moldable and deformable, that only the part of the design to which we can't make repairs and anytime. Also is not more expensive, and all the because we have very flexibility in the implementation part, and they can make change anytime they want. The combination of the elastomeric materials in the robotics area will change the design of the system. Could be an hybrid system. it's important to carry on about a good study and characterization of the materials. And finally, thank you, Kunazit, and thank the student chapter of the staff, because they are the ones who always motivation of to develop this type of the project. And thank you to the entire uh, team in general for this opportunity to participate in this congress. Um, any comments, any additional information and collaboration if you want one. And if you have any question for me, I will be painting my emails, my personal emails and my institutional emails, or through that platform. Thank you so much.